Well, hello YouTube again. Certainly didn't take very long to get some feedback on my video from yesterday about a redstone fence retracting machine. And now based on that feedback, I'm going to present you a much more compact design today. Now, this design comes from someone going by the name of PolarizedIons. So I'd like to be sure to give him 100% credit for this design. I've even copied his color scheme. From the top, this design looks and acts the same as the one that I showed you yesterday, substantially different. I'm going to build that for you in just a moment. Now, this time, I've decided that I will give you some preliminaries so that you can go and collect some resources before starting on this design, so you can pause the video. And so let's have a look here. I put these in the chest. You're going to need 7 sticky pistons. Now, 5 of them are for pushing and pulling the fence. So if you wanted a bigger design, you need more. And 2 of them are for part of the control circuitry. You're going to need 2 water cauldrons. This is a really cool approach that is used here with some comparators. Okay, so you need 2 water cauldrons, 2 buckets of water. You're going to need 5 redstone torches. That's for putting the pistons in their default extended state. We're going to need 5 repeaters. So it's possible we could make this design not need repeaters, be slightly larger, but also slightly less scalable. We're going to need 19 blocks that we're going to place redstone and other components on. We're going to need, in terms of critical components, we're going to need 2 half slabs onto which we will place the buttons. We need 2 comparators for detecting the cauldrons, and we also need a total of 6 repeaters. Now these 5 are for the blocks that connect to the redstone torches. So if you wanted to extend the design, then you'll need more of those. And then this extra repeater is part of the control circuit. For this design, you also need 8 pieces of redstone, and then you need some fence, however many you're going to place on the top. In this design, it's 5, and then other building materials for your ground level. For the hole, now is much smaller than it was last time. Okay, so this one is 7 blocks wide, 4 blocks long, and 4 blocks deep. This time, where I'm also starting with some cornerstones here that would go at the bottom of the hole over there to show you the alignment from the beginning. So to start with, we're going to need to put down our tower that powers the pistons. So I've decided to use the green block just like PolarizedIons did. So 1, 2, 3, 4, 5. Okay, so our pistons are going to go above this. We can put our redstone torches on top, and the sticky pistons on top of that. So to control this, we're going to place down a bunch of repeaters. So let's grab those. Okay, so each of these repeaters is going to bring power into these redstone blocks, right? So when you bring power into a redstone block, then if there's a redstone torch attached to it, then that redstone torch will turn off. So right now we're in the extended state. When we power these blocks, then we will be in, then they will retract. So now so the green blocks are representing the part of the circuit that controls the pistons directly, and here we're using the purple blocks to represent the control circuits. So we're going to distribute power to these, and since we are going to weakly power these blocks by putting redstone on the top, we need repeaters to pull power from the block. And so when we bring power into this block, we're going to need a repeater here. And so let's build the circuit that is going to connect, that is going to constitute the control logic. Let's do it in the order in which it will make the most sense to in terms of causality here. So what we're going to do is we're going to put a sticky piston here and a slab, half slab above that, and a button on top of this. Okay, so when we push this button, it's going to extend that piston. What are we going to put against that? We're going to put a cauldron and some water in that cauldron. Okay, so what's going to happen here is when you push the button, that cauldron is going to get pushed out, and we're going to make it come up against a redstone comparator. It's a cool design here. So let's do that. So you need a block here. I'm going to hold down Shift so that I don't change the setting of this, and I can place that there. And I can then turn around here and put on a comparator. Okay. So now, when I press this button, it will engage the comparator. I don't know if you saw that blinked on. Okay. So now the way we're going to connect this up is we're going to place a block right here. So I'm going to hold down Shift again, place a block here. Okay, so now when that piston when the piston pushes the cauldron over, the comparator is going to detect that there are contents in the cauldron, and so that will be activated, which will strongly power this block. That's kind of an important aspect of what's going on here, that this is strongly powered, because I am going to place some redstone dust here and this will get powered. So if you could look at the Minecraft wiki and see the distinction between weakly and strongly powered, if this were weakly powered, like this was just redstone dust, then this block would be powered, but it wouldn't power any of its neighbors. But since this is a comparator, then it's going to strongly power this block, which means it also powers its neighbors. And this is its neighbor. So we're going to use this redstone right here to send a signal around to this block. Okay, so this redstone is going to weakly power this block, but you can take a signal from a weakly powered block by a repeater. Okay, so that repeater will then power that redstone. Okay, so let's look at this in action. Right, there you go, that's the main mechanism. So now all we've got to do left is hook up the equivalent button components on the other side. So we're going to get a sticky piston over here. We're going to put a cauldron on it. Fill that with water. Okay. And now we need to connect. We're going to need a comparator and a block and a to carry that signal over to the other side. So here's a circuit that's going to carry it over. Need some redstone dust to conduct that signal. Then I'm going to put a block here. So actually I'm touching the hitbox of the redstone dust on the side. So it's going to put a block right here where I want it. And now I need to come around here and put on a comparator that will detect when the cauldron is moved over. And finally, I need to bring the signal down from the comparator to the redstone dust. Oops, so I didn't hit Shift there, so I put it in subtract mode. When I hit Shift, it's going to make me fall down. But anyway, there we go. So when the cauldron comes over, up against the comparator that will strongly power this block, which will allow this to be powered, sending a redstone signal over here, weakly powering this block, which can be extracted by this repeater and sent along there. So now we can finish this part. Half slab here, and a button there. And I push that button and watch it retract. Okay, so just as some finishing touches, I'm not going to do the whole thing this time. I will put on the fences and some slabs just so that you can see it in action. There you go.